Hi, this is Involved Innovation YouTube channel. In this video, we will see how to create a Kafka Producer API using Spring Boot. Before going to this, we will see what are the different topics we are going to cover here in this agenda. First, we will see about the overview about the Producer API, and then we will also just cover the basics of other APIs, Consumer API Streams, Connector, and then we will see how to create a Spring Starter project which will work for Kafka, and then we will create the AVRO schema. In this particular example, I'm gonna use string as the key and then AVRO as the value. So whenever the producer produces, it serializes that information in this particular format and then it sends to the Kafka broker. And then we will use a maven plugin to generate the POJOs using the AVRO schema, and then we will create the REST controller. The REST controller will be the starting point, and when you trigger this REST endpoint, which will be post method, you can able to send the message to the Kafka. And next we will see about the Docker setup. For this I am gonna use a Schema Registry, the broker. I am using Zookeeper to manage the brokers. You can either use Zookeeper or Kraft, and then we will test this application. With that being said, we will now talk about the overview. If you want to learn more about broker cluster, I have a video tutorial already available in YouTube. You can go over that video. Here we have a cluster. Let's take we have 3 brokers. The broker can be a container or it can be a physical machine, and then more number of such instances join together to form a cluster. The partitions are the number of logically separated partitions for a particular topic, and then these partitions are the real place where the message will go in. For each partition, if you have a replication factor set, then you can able to see an in-sync replica or out-sync replica. The in-sync replica are the one whenever the message comes to the leader replica. For example, here for the orders topic, we have 3 partitions and each partition has a replication factor of 1. So the partition 0 is present in the broker 1, which is the reader replica. The partition 0 leader replica is present in the broker 1, and then the partition 0's in-sync replica is present in broker 2. So whenever you want to read a data from the partition 0, you will be contacting the broker 1. If this broker goes off completely, then you will be using the in-sync replicas as the replacement. The Bootstrap broker is the one where your Producer API or Consumer API or Streams API will connect to, and then this Bootstrap broker will give the metadata about other brokers and what are the different brokers partitions. For example, it will give information like if I need to send message to partition 0 of this orders topic, if you contact the Bootstrap broker, then it will give you information like what are the different topics the broker has, where is the reader replica present for that particular partitions. All those things we will get from the Bootstrap broker. Any broker can be a Bootstrap broker. For this, I am just considering broker 2 as a Bootstrap broker. All the communication happens to that Bootstrap broker. Offset is the running index. The running index starts from 0. So offsets mention what is the message number in a particular partition. So this offset guarantees message ordering. The message ordering is guaranteed only if the messages are present in a single partition. There are like different ways you can connect to the Kafka cluster. For example, here we are going to discuss about Producer API. Producer API enables us to send the message to the broker. This is a way to produce the message, and then you have Consumer API. Consumer API is used to consume the message from a broker, and then you have connectors. The connectors can be of 2 types. One is source connect and then the sync connect. So the source connect is to get the data from any external data source. For example, the external data source can be a ActiveMQ or Postgres, and then from there the messages will be sent to Kafka using the source connect. And then you have connect sync. So this facilitates us to send the message from Kafka to other data sources. The data sources can be here like any messaging services like ActiveMQ or RabbitMQ, or any database services like Postgres, and it can be anything. There is also another powerful API, that is Kafka Streams. Kafka Streams you can both produce and consume with the help of this Kafka Streams. To learn more about Kafka Streams, refer my video tutorial. I have a very elaborate series on Kafka Streams. And then a KSQL DB, you can query this DB. This DB will give you a snapshot of what is the state. We will see what we are gonna do here with the help of Schema Registry. Here in this particular piece, as I mentioned, the key is gonna be string and then the value is gonna be AVRO. So with the use of AVRO, you can able to validate the schema when the message comes in. For example, if you have a message like name and then ID, if you are making this name and ID as mandatory fields, if the incoming message doesn't have name or ID, then it will be rejected because it will validate with the Schema Registry which is already there, and then if it is not matching, then the messages won't be sent to the Kafka. So by this way, you can able to validate with the help of Schema Registry. There is an option to evolve schema. For example, if there is a new message comes in and which has additional property, and then if you set the Schema Registry as evolved schema, then it will make sure the Schema Registry schema is backward compatible and all the new fields will be automatically registered. Here this will be utilized by both producer and then the consumer. Now we will create a Spring Boot project. To create a Spring Boot application, go to start.spring.io. Here I am using Maven, so I am selecting Maven. Java version is 17, so I am selecting 17, and then the language is Java, and I am using Spring Boot version 3.1.4. You can use any version of your choice, and I am just making some modifications to the group. Now we will add the dependencies. To start with, search Kafka here and Spring for Apache Kafka. Click this, and then Spring Web. This is to create the RESTful services, and then we will also add Lombok dependency. Now we will click generate. So this will generate the Kafka, and open this here. We have downloaded the Kafka zip here. Here extract this file. Now we have extracted this Kafka, and open command prompt here. Enter the command idea dot. This will open the IntelliJ in this particular folder. You need to have IntelliJ already installed in your system for this to work. In your case, if you don't have IntelliJ, and you can use any IDE of your choice, we will see what we have in the POM file. So here we have Spring Boot Starter Web. This is for the RESTful API, and then we have Spring Kafka, and then we have Lombok to reduce the boilerplate code, and then we have the test. And in addition to that, we also need other Maven dependencies. We will add those Maven dependencies here. We need io.confluent. So this is for the AVRO serializer, and we also need AVRO. Now we will create the AVRO schema. So to create the AVRO schema, you need to create a AVSE file, and here I am gonna put this in the resources folder. So the resources folder will be in SRC, and here in the main you will have a resources folder, and then I will name this as order value.avsc. I already created this AVRO schema, so I will copy and paste this. We need to define the name of this particular AVRO schema. Here I named it as order value, and then you need to define the namespace. So here I gave the namespace as com.wispath.kafka producer.generated. When you try to generate the POJOs based on this AVRO schema, this will get used as the base package. My base package is com.wispath.kafka, and then here I am just keeping it as generated just to make sure the files generated based on this AVRO schema will be put into a package name generated. And then the documentation, you can specify what this particular AVRO schema is about, and then you need to specify the type. Here this is a record. You need to have a mandatory field, that is fields. The fields is the one which has all the information. Before saying that, we will see what all the different fields I am going to add here. We are going to add order ID, which is of string data type, and then order type, this is of enum. With enum we can able to define all the possible values which you can get for this particular field. And then you have order items, and then order status, and this order paid, and then total cost. So order status is also enum, and this order paid is boolean, and then we have total cost which is of double data type. Now go back to the AVRO schema which we have already created. Now I am keeping the order ID. The order ID inside the fields array, you need to define each field in their own object. Here in this case, I am first going with order ID. So you need to define name as order ID, and the next property is type. So the type takes type and then doc. So here you can also define this data type outside. I just want to document this particular order ID, that's why I kept it as string, type is string, and then documentation unique order ID for each order. And then next, the type I am keeping it as object, and inside type there is a type field which specifies the data type. Here this is a enum, I mentioned this as enum, and then the possible values will be defined in symbols, and this is a string array. The possible enum values for the order type are standard order, long lead time order, pre-order and back order, and you also need to specify a default value, and then you need to have the name, and the name is order type. And then the next one is order date, and this is of string data type, and then you have a documentation items order date, and then you have another enum order status which has the possible values pending, unshipped, partially shipped, shipped, cancelled and pending availability, and the default is pending. And there is a next field is order paid. This is of boolean data type. With the documentation we specified this is to note whether this order is paid or not. And you have total cost, so this is the total cost for this particular order, and this is of double data type. And then you have order items. This is one of the very critical information. So the order items is an array, and this order items has many number of order item. Inside type object you have type, and this is of array data type. Whenever you have array data type you need to specify items, and inside items you can specify a record. So this record is specified as order item, and this record has multiple fields. The first one is item name, and this is of string data type, and then item price, and this is of double data type. So here in this case I gave the value string and then double directly here, and now we have defined our AVRO schema. Now we will see how to generate POJOs based on this AVRO schema. So to generate the POJOs you need to add a maven plugin. So go to pom.xml. Here in the plugin section you need to add the AVRO plugin. I need to also add AVRO maven plugin version. So here I will go to properties, and it is a good practice to put all the versions here in the properties so that you are not dealing directly here, so you can able to see all the versions here, so it will be easy to manage. Now go back to the plugin. So I will try to explain this plugin here. So this will generate the POJO classes based on the AVRO schema, and then here you have source directory and then output directory. The source directory is the place where you can read the AVRO schemas from. src main resources and AVRO schema. So I need to create a new folder, new directory, and the directory name is AVRO schemas. You can put it anywhere. So AVRO schemas, and then I will move this to AVRO schema folder. Refactor. Perfect. And this is the place where output POJOs need to be generated. So this is the source directory, and as I mentioned here you also have the package information here in namespace. So this will be the root. So src main java. After that this file will get created in com, vispath, Kafka and generated. We already defined com, vispath and Kafka as our base. So this will create a new directory named generated, and this will place all the POJOs inside generated. And then we need to define create builder true and then string. So this is one of the crucial information. Your data type as a string. By default it will make this as char sequence array, but if you don't want that, if you want to make the string as string data type in Java, you can put it as string. And then the field visibility you can put it as private, so that the fields are only visible to the getters and setters. And then you can put the builder field visibility. For this also I placed it as private. Now we are done. We need to put the Confluent repository. By default this will try to reach the maven repository because that's what we have presented here, and this particular version is not present in the maven repository, so you need to add the Confluent repository. So we have added the repositories. So this is the information which we need to add. By default it will always take everything from the Spring and then maven repo. Here in this case I want to take from Confluent repo, so I have placed the packages.confluent.io URI and the ID is Confluent. So now we are done with our basic initial setup. refresh this project, reload all maven projects. This will take some time. So now we need to run execute maven goal. Click execute maven goal and here enter the command mvn clean and install. Now this will download all the necessary jar which we have specified in the POM, and this also will create the POJOs based on the Avro schema. Now the build is success. That means all the necessary jars are downloaded and it created the generated package. And if you go inside, you can able to see the enums. The enums will be specified as a separate file. For example, here in this case, the order status is a enum, and then order type is a enum, order values are root, and this has all the fields whatever we have defined, and order item is array, and this order item inside array you will have this each and every order item. Now next we will start with the Kafka configuration. For this I'm gonna use the application.yaml. So this is my preference. If you want to keep this as a properties, that is good to go. YAML provides a little bit more structuring as parent and then child, so I'm gonna use YAML format. I'm gonna change, so go to refactor and then rename. Here instead of keeping this as application.properties, I'm gonna keep it as application.yaml and then click refactor. Now we will start creating the configuration for Kafka. First we will start with the server port. So whenever this application runs, by default it will use 8080, but just in case if 8080 is used by another application, your application won't start. So for that you can able to specify a server port by yourself. Server and then define port here 8089. I'm just picking a random number here. You can choose any port number of your choice. And here we need to start with the Spring configuration for Kafka. So Spring is the root here, Kafka and then producer. And first we need to define the bootstrap server. So if you remember my previous video or the intro to this video, our producer API will communicate to the bootstrap broker. The bootstrap broker in this case is the broker 2, and this bootstrap broker gives us all the metadata about like what all the different partitions are present in different brokers, and just in case if you want to send message to the partition 0, then you need broker 1 details and configuration, all those things it needs, and then you need partition 0's in sync replicas. All those information you can able to get from the bootstrap broker. Bootstrap broker is not a specialized broker. Any broker can be a bootstrap broker. So you need to specify the bootstrap broker's URI. So for this I am using the Docker. If you are new to Docker, don't worry, I will go step by step. I also have a Docker compose file. So in your case you just need the Docker in your system, and I will provide the Docker compose file, and if you are using Docker compose up, it will get all the necessary images and then it will run this in the container. First we need to give bootstrap broker, specify bootstrap servers, and then the URI for bootstrap server is localhost 9092. So this 9092 port I have defined in the Docker compose file, that's why I am keeping it as 9092. In your case, if you are using Confluent Kafka, you need to give a different bootstrap broker, and if you are deploying this to any other region or cloud providers, they need to make sure you are providing the correct bootstrap servers. For this I am gonna use my local container brokers, and then you need to define the key serializer, and then you need to define the value serializer. Whenever you send a message to Kafka, by default all the messages in the Kafka are in binary format, but you can serialize and deserialize the values to different formats. There can be different formats such as Avro, JSON, string, integer, protobuf. In this case I am using key as a string and then value as a Avro. So you need to define properties, and the property names you need to provide in the square brace. Here the property name is key.serializer, and the string serializer is present in org Apache Kafka package, and which we have placed as a dependency in our POM file. org.apache.kafka.serialization.string serializer. Copy this and paste it again. Here instead of key, this is value. In YAML file you need to make sure all the indentations are correct. For this I need to use the Confluent AVRO schema. So this is coming from the package io.confluent. This also we have added to our POM dependency io.confluent.kafka.serializers.Kafka AVRO serializer, and then you need to provide the schema registry URI. So here, whenever the producer sends message, this will be validated by schema registry, and then the schema registry will validate the message. If this is in alignment with whatever it is defined in the AVRO schema, then it will pass this message to get persisted in the Kafka broker. This schema registry, in my case, I am having this as a separate image, and this will be running in a separate container. So whenever you produce the first message, it will take the AVRO schema, whatever this based on, and then this will be placed in the schema registry. So for this, the properties and then the value name is schema.registry.url http. Here http is important because it need to have the protocol, and then you need to specify URI. In my case, I'm using 8081 in my Docker Compose file. That's why I am specifying this value as 8081. And then the application ID, and I'm just naming this as order app, and then save this file. Now we are done with our initial configuration. Now go back and we will start with our Kafka coding. So to start the Spring, to understand to use that particular configuration, you need to provide the annotation enable Kafka. And now I will create a new package and I will name this as publisher. This is where our Kafka publisher code goes. Publisher is the package name and the file name Kafka publisher. Now we need to define this as a component so that the Spring will manage this bean. You need to use Kafka template. The Kafka template, I'm keeping it as private final Kafka template, and the key is of type string, comma, value is generic record, and this is Kafka template. So here I have defined this as final. We need to define the constructor. So if you are familiar with Spring, we will usually use @AutoWired. So here @AutoWired is a method level injection. We don't want that. We want constructor level injection. So for that, we can define our own constructor, but with the help of Lombok, we can simplify that. If you put this as record our constructor, it will create a new constructor for us with this Kafka template as one of the input argument. And I will also add SLF4J configuration. So this is for logging, so you can log with the help of SLF4J. So here I will create the method which publishes the message to Kafka public, and this is a void and produce Kafka message. With the Kafka template, you can send message to a particular topic and then you can pass the key and then the value. So here in this case, I'm using Kafka template dot send, and here I will take topic as one of the parameter. So I will put it as string topic name, and here topic name. For now, I will just put it as key and then value. We will try to create this key and value. I will create the REST controller now, and we will come back to this shortly when we complete the REST controller. Create a new package, name it as controller, and then name this Java file name as order controller. Use the annotation REST controller and define SLF4J. And here you need Kafka publisher. You already created a Kafka publisher class, so define private final Kafka publisher and then Kafka publisher. Since you are defining this as final, you need to create a constructor. So here I will use the Lombok annotation to create the constructor for us. So this is record args constructor, and then we will start with our post mapping. So for this, I need to create a post method because I need the request body coming in. So I am creating a post method. So to create a simple post method, use the annotation post mapping, and you can specify the path here. So here I am just keeping it as double quotes /order/create. Now we will create a method public create order. So the return type is response entity. So this takes a request body. So I need to create some pojos. I will name this pojo as order. Create class, click create class order, and here I want to put this inside the model. And for that you also need some enums. So first we will create an enum named order type. This enum values are standard order, long lead time order, pre-order and back order. And then we will create another enum. This enum is of type order status, and this order statuses are pending, unshipped, partially shipped, shipped, cancelled and pending availability. You also need to define order item. This order item is the individual order, and this will be present inside the order as array. And then the first type is private string item name, private double item price, and you can make use of lombok to generate the getters and setters. You can use @data annotation. That's it. Now we have defined the enums and then order item. Go back to the order class here. So here we have string id. Order type is a enum which we have created, and that is order type. And then you have order date as a string, and then order item as a list. So you are using the collections list, and then you have order status, and then is order paid as a boolean and total cost as double. Now you need to use the @data annotation from lombok to create getters and setters. Now we are done with our pojo. Now go back to the controller here, and here we have created this order. We will create a try block, try and catch. Here we will catch all the exception. I will just put it as log error, and this log error we are getting from SLF4j, and the log has different methods to specify whether it is of error, info or debug or warning category, which is error sending message to Kafka topic. And we also add this exception, and you can use this curly braces as a placeholder. So comma exception dot get message, and then return new response entity, and then this response entity is of string type. Copy the same message here, paste it inside, and then you will put HTTP status as internal server error. Now we will use the Kafka publisher. So Kafka publisher dot produce Kafka message. First one is topic, so I'm just defining this as order, and then the second parameter is order. We haven't created that yet, but we can create that. And here I will just copy this response entity, this particular piece here, copy and paste this, and here message successfully sent to topic. Here the HTTP status is HTTP status accepted. Now go back to the produce Kafka message. Here we will create another parameter which is of type order. Now we need to populate these values to the order value. So the order value is this one which got created with our AVRO schema. Order value equal to new order value. So if you go back to the order value, so this is the one which is generated. If you are creating your own, you need to make sure this implements a specific record. So here I have generated, so this is coming with the help of the maven plugin. So now I need to map the value which is coming from the JSON in the payload to the data which I need to send as a value. So here we have order ID, and this order ID we are getting from the ID which we have created, and then we have order date, and then we have the order status, and then we have order type and order cost. Now we have defined the mapping logic. So it maps this particular field order items, and we will be passing in the order item, and then based on that we have stream and stream.map, and then that map gets as the new order item. Here we are passing the item name and item price as the constructor value, and we are collecting it as a list. So now we are done with our mapping logic. Now we will send this particular information. Now keys is a string type, so order dot get id, and then value is AVRO. So this is order value, and then the result is of type completable future. In your case, you can also use type inference. So to use type inference, you will just use var. You can define this as var and then the field name, but I just want to keep it as completable future so that you are understanding what is the type we are getting really. And then send result and then the key and then the values of type generic record. With the completable future, we can able to define what happens if there is an error. So for that, I have already created a simple future result, and here this future result, when complete, it gets result and then the exception. So the exception, if it is equivalent to null, that means the message sent successfully to the Kafka topic, and you are also getting the topic name and then the record metadata partition and then offset. If there is an issue, we will be just logging in the error message and then we will be logging that particular exception as well. Now we are done with our application. So now we will see about the Docker Compose file. In the resources section, I will create a new file. I will name this as Docker Compose.yaml. I already have this, so I will copy and paste this here. You don't need everything. I will just say what are the different things you require for this particular project, but there is no harm in keeping everything so that you can able to follow along with this complete series. You need Zookeeper. Zookeeper is the one which manages your broker. It helps you in leader selections in case of a broker crash, all those things. And then the broker is the real instance where you will have the topics, partitions, all those things. Here this is where we have defined the ports, and then the schema registry is the place where the schema will be validated, and the connector you have both source connector or sync connector as I have defined, and this we are not using in this particular example. And then we have KSQL DB server, and then we have control center. The control center is the one which gives us a very nice UI. You can able to see what is the message you are getting in and coming in, all those things. And then you have KSQL DB CLI and then KSQL data gen, and then you have REST proxy. These things we no need for this particular application. You need to have Docker, so you don't require any Docker knowledge for this particular piece. Having a Docker knowledge is a plus, but if you don't have, don't worry about it. This is the only file you need to use to set up an environment for this tutorial. And open the terminal here. You have Kafka and go to cd src cd main resources. Go inside the cd resources. You have the Docker Compose file here. So enter the command docker compose up and -d. -d is the shortcut for detach. So this will detach once this particular containers are up. If you are not giving this -d, then you will see all the logs here, and then if you terminate this terminal, then that particular container will go off. So this will get the images, what all the different images I have defined here. It will get all the images and then it will run this in the container. So now if you parallelly open Docker, since the root name is resources folder, so it is naming this as resources. So now it starts with different containers. It has Zookeeper. Everything is now working fine. We can open the control center. So to open the control center, go to localhost. The control center port is 9021. So enter 9021. Now we have our control center open. It will open the cluster. So click control center.cluster. Here you can able to see all the services which are running. So in my case, I need to go to the topic. Here I can create a topic, give this partition as 3, and then here I will put the topic name as order. So here for this application, I am using only one broker because that's what I have in the container. You can also have more than one broker. That is possible with the help of the Docker Compose, but this is simple here. We are using only one broker. So click create with the defaults. Now we have created. To see the messages, you can define the offset from where you need to see, and you can 0 partition 0, you are not seeing anything here, and then 0 partition 1, you are not seeing any messages here, and then 0 partition 2, you are not seeing any messages here. That means like there is no messages coming in. That is what we are expected. And here go to the application and then go to Kafka Producer application and start the Kafka Producer application here. This will take some time to load your Spring Boot application, and once it is successfully started, you will get started Kafka Producer application. You can test this post endpoint with any application. In my case, I am using Postman. So in the body we have 1 to 4 standard order, and then order date, and then the item as an array, and we have only one item, and then total cost is order paid is true, and then order status is shipped. Now here we have the URI as order, and then create the method is post, and click send here. Error sending message to Kafka topic. Now we will go and see what is the error we are getting in. It says invalid string serializer. So go to the application.yaml, org Kafka serialization and string serializer, Apache Kafka, and here we missing the common here. So common dot, the package name is wrong here. Now the application is started. Click send. The message successfully sent to Kafka topic. Now the things are working fine, and you can able to see it goes to the partition 2, and then the offset is 0. So go back to the console here, and you can able to see a new message published in partition 2. So if you check in some other partition, the message won't be present. The message is not present in partition 0, and no message present in partition 1. So here the message published to partition 2, and you can able to see the message here. This is what we have published, and we will try to publish another message, and if you change the order ID, it goes to a different partition. So here instead of 1 to 4, I am giving it as 1 to 5, and I will just keep everything same, and this is sent to the partition 0, and then the offset is 0. And now you can go to partition 0, and yeah, you can able to see this message 125, and I will try to send another message 126. The message is successfully sent, and go back here, and it is sent to the partition 2, and this is with the offset 1. So if you go back to partition 2, you can able to see 2 messages here. Now the things are working fine, and you can able to also check the schema. If you click schema, you can able to see what is the schema which we are using for value and what is the schema we are using for key. So in this case the key is a string, that's why we are not seeing anything, but here in this case this is a Avro schema, so we are seeing everything here, like whatever we have defined. We can able to see that we have order ID, order type, order date, and everything is mandatory. If you want to define anything as a non-mandatory field, you need to define, then you need to add a new property, default equal to null. So now I will try to send a message without, let's take I am trying to send a message without order type. Let's see whether we are getting any error or not. I'm just commenting out this piece and rerunning this application, then send this message. Instead of 126, I will just put it as 127. Sent. Error sending message to Kafka. Error serializing Avro message because you are unable to find the order type, because order type is mandatory here. That's why it is erroring out. So now we have successfully sent Avro message as a value, and then string as a key here with the producer API. Thanks for watching. For complete Kafka series, subscribe to this channel.